bit of luck, I should have them done by then. I'll probably tell you tomorrow whether I'm on schedule to do that or not. When you get your grade back, you won't just get your test grade back. What you'll actually get back is everything. In other words, what your homework grade is, participation grade, extra credit grade, test grade, and overall grade, right? So you pretty much know everything that you would want to know. I'll also be putting online, once everyone who's done the test has finally got, what am I getting at? Once everyone who could do the test has done the test, I'll put the solutions online as well for you, so you can actually look over your, see where you went wrong, if you went wrong at all. Okay, so good morning, officially getting started. We are beginning a new section today, a new chapter. And we're going to look at sampling. And give you a kind of big picture idea. A lot of what I'm going to be talking about today, and I kind of apologize the fact that I'm going to be doing a lot of talking, is that we're going to be looking at how we collect information and the different terms that are used in sampling. And so we're going to be looking at that, and I'll talk about examples of different types of situations where you would collect data and some of the pitfalls that you run into when you want to get good data. So we'll start off with the fundamental rule for using data to make inferences. If you collect good information, when they say you make an inference about it, what it means is that you can collect that information and use it to predict what you think is happening in the big world. So suppose I was interested in the average age of American people who live in America. Then I could certainly do a census. And a census is when you go around and you ask every single person in America, how old are you? And you assume they tell you the truth. But that is extremely difficult to do. Would you agree it's hard to know where every person in America is at any given moment in time? You've got addresses, but you're going to miss some. It's extremely expensive. And the only people that I know who do censuses are the government. And in America, they do it like every 10 years. I don't know if any of you've had to deal with that, but you get a basic form and they ask everybody, it should be everybody in America. Do the same thing in Scotland. They have a census every 10 years. So most Western countries will have a census. And it's a kind of expensive way to find out what you want to know. But let's suppose that you don't want to do a census. You could do a simple sample. A sample would be where you went out and maybe only asked 1,000 people their age. Now, if you do a good job at collecting that sample, right, collecting that data, if that data, that sample, is a fair representation of the population, right, that's everybody, the larger group, with regards to the question of interest, right? So if I'm interested in how old people are in America, if I could find a good way of asking 1,000 people, 1,000 random kind of, some are young, some are babies, that's their parents, I'm assuming, right? Some are old, whatever, a good spectrum. Then if I came out with the answer 32, then I could make the inference that I think the average age of all Americans is 32, even although I only used 1,000 people. So you can see the idea of a little sample can sometimes tell you what's going on in the bigger picture. And that's essentially what sampling's about. Finding ways of collecting information from small groups of people, typically, and using it to make a judgment call about what you think the bigger picture is, right? The inferences, we would say. So here are some terms. Population. That is all the people who belong to the group you're interested in finding out about. I'll give an example of how populations can change. If I was interested in the cigarette smoking habits of high school students, right, whether they smoked or not, right, that kind of thing, then the population there would be high school students, agreed? I wouldn't go and ask 1,000 people, and some of them were 42-year-olds, right? And some of them were 3-year-olds, right? That would not be a good sample. Would you agree? Right? Isn't the population here very specific? High school students. If I was interested in the age of people in Washington state, then that would be the population, right? Everyone who lived in Washington state. So if I was going to collect a sample from that, wouldn't it be a good idea only to ask people who lived in Washington and not people who were visiting from Texas, right? So you can see your population is important, because if you know who you want to ask, can't you then adjust your sample to be only from that group of people and not some other bigger group that distorts what you're after? Now, a sample is a small selection of individuals who should come from that population. That's essentially what I just said there. Now we have a term called selection bias. Now this occurs if individuals, don't know why I said if individuals are selected for the sample are chosen in such a way that they do not reflect the population in general. Okay, suppose I was interested in the average wealth of a person who lived in Washington state, right? So I wanted to find out how much money on average people were worth. And I decided that my sample was going to be on Bainbridge Island. So I only asked 1,000 people in Bainbridge Island how much money they made, right? Can you see that would be a bias? From what I know, isn't Bainbridge Island where the rich folk live? Mostly. There are poor people, I'm sure, everywhere. But in general, would you agree Bainbridge Island is not a fair representation of Washington state? Would you agree picking people from Seattle wouldn't be a good idea either? So if you wanted to get, if you did that, that would be called selection bias. In other words, the people you chose to ask the question to weren't a fair representation of what the entire population was like. If I really wanted to know what the average wealth of Washington state people is, shouldn't I be picking people on the east side of the mountains as well? Shouldn't I be picking people in Spokane or something, right? And shouldn't I be people in Port Orchard and people over in the Ocean City and, you know, a bit of everybody, right? That would be a good sample, right? People from Seattle as well, right? A bit of everything. Selection bias is not good. Another example of selection bias. Suppose I was interested in how people were going to vote in the next general election, right? The next presidential election. And I decided only to ask people, because I did it on TV and gave them a link to go and vote. And I only asked people who watch CNN. Why would that be a selection bias?
Isn't most news lean towards one side of?
Yes, CNN, I think, unless you work for CNN, in which case they will deny it, is liberal.
Mm-hmm.
Right? And Fox, they may deny it as well, but Fox is conservative. Agreed? So only asking people who watch one particular news station is probably a bad idea if you're interested in how all of Washington state or any state was going to vote in a general election. That would be an example of selection bias.
The least biased of all would be Babylon Bee. They're neither.
Okay, I'll take your word for it. How about
They're a
this?
satire site.
Didn't know that. I thought it was the Sci-Fi Show. Where was my brain going? Oh, how about this one? You're interested in people's opinion on abortion, right? Are they in favor? Are they against? And you randomly phone 1,000 people. Where's the selection bias in phoning 1,000 people? Who do you not get to talk to?
People who don't have phones?
People who don't have phones, would you probably assume that a large proportion of them don't own phones because they're not very rich? In other words, they're poor. Would that seem a reasonable assumption? Some don't own phones because they hate them, right? Do you see, in that case, you wouldn't be getting every perspective, right? Because maybe poor people have a different opinion of abortion than rich people, or middle class people, or whatever group people belong to. Do you see that could introduce bias? Right. So be careful when you decide who you're going to ask your sample, because there could be selection bias in it. Oh, by the way, when you do these questions, when you eventually get to see, oh, there we go again. When you eventually get to see the questions, they give you a little story and then they give you like 4 boxes and you pick the right one. So there's not going to be a calculator involved in this one. The book separates these two, and I'm really not sure why, but we'll come to that when we do it. Non-participation bias and non-response bias. There is a subtle difference, I guess. Non-participation bias. You ask 1,000 people, and it's a very good representation of the population, right? It's a good sample. But people say, I'm not telling you. And if enough people say, I'm not telling you, right, it's a non-participation bias, right? They're not taking part, right? It's also a non-response bias. Can you see that if enough of them aren't asked, telling you, maybe that is going to distort what you believe the truth to be? Let's be silly about some. Imagine you went and asked 1,000 people, have you ever committed a felony? Right? Can you see a lot of people are going to either lie or refuse to answer that question? And if you only use the people who answered it, couldn't you come up with the answer that Washington State is a very safe state? Only 0.01% of Washingtonians have ever committed a felony, or at least that's what I got from my sample. Can you see the non-participation bias causing that problem? Now, if only 2 people out of the 1,000 didn't answer it, and we're assuming the ones who did answer it didn't lie, which is a different kind of bias, right? Wouldn't the data be pretty good, right? If only a couple of people don't answer and you're assuming that the question is pretty safe, then you would get pretty good data from that. Give you another example of where non-participation bias can kick in. It also can kick in, they should really cover, this is covering 2 kinds of biases. One is, I'm not telling you. And the second was, I'm just going to lie because I don't want to tell you the truth, right? If you did a survey on high school students and you were interested in their illegal drug use, can you imagine the non-participation bias you could get out of that? Right? So if you still want to know that information, because it's very important to know what are the drugs that young teenagers are taking now, because from year to year and from decade to decade, doesn't that change, right? New drugs, some drugs go out and, other drugs come in, and you want to keep track of what's going on for health reasons and for trying to prevent it as well. That you would have to figure a better way of asking them that question. So if you just give them a questionnaire and say, right, put your name at the top and answer this questionnaire for me and I'll take it back. Can you see why there'd be a lot of reticence there on getting the truth? So a couple of the tricks that they use for very sensitive things like that. You make the survey anonymous. You don't put your name on it. Secondly, you don't even take the thing back from them. You put a box and you say, when you're finished, just slide it in that box. There are already 20 or 30 in there. Give a good shake if you feel like you want to. So you try and separate the problem, right? And you can very often get some pretty good information from that. Right. Now, you're going to hear a term quite a lot called a simple random sample. This is the ultimate best kind of sample you can ever get. And it's a sample where every single person in the population has the same chance of being chosen from your sample as anybody else. So if you can figure a way of collecting a sample that's random like this, and you take care of the kind of things like non-participation bias and all the other things that might go along with it, and you get very good data from it. You can make very good inferences in many situations. We've already mentioned the census. That's when you ask everybody. You'll see a term sample survey sometimes. A sample survey is just another name for a sample. Non-response bias is basically, I'm not telling you, which we've already kind of covered in non-participation. You know, I guess the only difference between non-participation and non-response is non-participation, it happens when you send out letters to people's houses and ask them to reply, and they just don't bother. And non-response bias is you've got the person in front of you and you ask them and they say no. I mean, the net effect is the same. Would you agree you don't get good information? So if you're looking for a little nitpicky difference, non-participation is they just never reply to the survey. And non-response is they either replied and said no comment, or you asked them physically and they said, I'm not telling you. Here's an interesting kind of bias. It's called response bias. If you ask people questions, and it's almost always going to be, it's strongest anyway, when it's a person physically asking the other person the question. They very often will answer it in the way that they think you want to kind of hear it. Most people like to be thought of as nice people, right? Most people want to be thought well. So if you're doing a survey and you go around and you say to people, what do you think about increasing your property taxes to update the school? Right? Now, if you ask someone that face to face, do you know a lot of people might think, well, I don't want to pay taxes. So if I say no to that, I'm going to look like a bad person. So they might say yes, even though they won't be in favor of it. Can you imagine not that long ago if people were asking you, are you going to vote for Donald Trump in the election? Can you see a lot of people might say no to that question? Not because that they weren't going to vote for him, but because they would think that there might be negative connotations put on them because of that, which is very sad. You should be able to vote for anybody you like within reason, but that's what it is. So that is a response bias situation. Any of these terms you want clarification, or you feel good about them? Very good. Okay, the last guy we're going to talk about is called the conservative margin of error. And it is the only calculation that we do in this first section. And it's 1 over n, where n is the number of the sample. So let me show you how that works. Okay, what we got in this class right now? Okay, we have got, including me, 27 people. So I'm going to do a quick survey with you lot. Okay, I can see most of you. Right. What's the easiest way for me to do this? Yes, you are going to say in chat, yes, if you think yes, and you're not going to say anything if you don't like this, right? So I'm going to ask you a question, and if you agree in it, you're going to say yes in chat, and then I can just count the number of people who's appeared on my chat, right? And that's how I'm going to get my sample. So you lot are going to be a fair representation of Olympic college students who take statistics. I think you probably are, right? Okay, so here we go. How many of you think I have got an accent? Okay, and the scores are in, and the answer was 20. So 20 out of 27 think I have got an accent. So I'm doing a quick calculation here and turning that into a percent. So 20 divided by 27 times 100, and the answer I get is about 74%. So 74% of Olympic College statistics students, if they heard me, would say I had an accent. Unfortunate that they're all wrong, but that's different. Now, there is a guy called the conservative margin of error. Oh, I better jump back so you can see what I'm writing. Now, whenever you collect a sample and you're going to use it to make an inference about the bigger population, right, which is all students are taking statistics, would you agree that there's chances that there's going to be a little bit of wiggle room? Every class that you
Mr.
ask that.
Robertson?
Yes, Alexis.
It was me actually. It
Julie.
says there are 20%, 27 participants.
Yes.
Aren't you part of that 27? Do you believe I'm an accent?
No. Somebody voted twice, you buggers. I stopped counting at 20, so I don't care what the others said. They didn't get counted. They were too slow. The others might be saying hi because they think it's time for us to do hi yet, which it isn't quite yet. So what I was saying is that let's pretend then 74% if you think I have an accent before I insulted you. If you looked at the other classes, couldn't there be one class might be 70%, the other might be 85%? There's going to be a little bit of variation. So this number called the conservative margin of error is a kind of, they've discovered it through experience, right? It's not a theoretical answer, it's just a practical answer. And it's equal to 1 over the square root of n. And then you turn it into a percentage. So I'm going to go 1 and divided by me, the square root of 27. So I'm counting that. And I'm going to call that 19. Okay, that's 19%. What that does is you can say 74% plus or minus 19%. You might have heard the term margin of error. You ever heard that term, especially when the politics and the election were going on? Do you know this poll, Kansas is going, Republican, 52% with a margin of error plus or minus 5%. You remember those kind of phrases that they use from time to time? That's connected to that. It's not quite the margin of error, but it's a version of it. It's the conservative margin of error. So in this case, what we could do is put a kind of range of what we think the right answer is. So it could be as low as only 55% of statistics students think I have an accent. And it could be as high as 93%. But now we have got a ballpark figure that we're pretty sure the real answer is going to be it. So do you see how this margin of error can kind of help us to come up with not just a single number, and we're pretending that's a true answer, but a range of values where we're pretty sure that somewhere in that range, the real answer lies. So I'm going to do another one with you. And you are going to, again, just say hi or yes, or you're just going to do a comment, right? And okay, my chat thing's not going to work anymore because I've got a tool. Do you know the little guy that's called reactions? No. Thumbs up. You're going to vote with a thumbs up now, right? If the answer to this is yes, okay? So I'm going to make a lot of assumptions here. I'm going to assume that you lot are typical OC students, which I don't think is that big an assumption, right? You are OC students, but you're a typical, right? You're the same kind of age group and whatever, right? So there are 27 of you. And the question is, how many of you have been to Mexico? One, two, three, four, five, six, seven. Is there anybody on the other page? 7. Okay, as best I could judge, 7 of us have been to Mexico. So I'm going to use that to see if we can make a prediction on what percentage of OC students have been to Mexico. So I'll convert that into a percentage. And the answer I get is about 26%. And we already calculated the margin of error. Remember, the margin of error was 1 over square root of n. And since the class hasn't changed any, it's still 19%. So it could be 19, as low as 7%, and it might be as high as 45%. So I would make the prediction that if you asked all of Olympic College students, right, everybody who is at Olympic College today, the answer, have you been to Mexico, could be as low as only 7% of you, but it could be as high as 45. Why do you think that range is so big?
Professor, can you explain where the 45 came from?
Oh, 26, add 19. And the other one was 26, take away 19.
What happens if our percentage minus the error is negative?
You just start at 0.1, because there's always somebody that must have said yes, unless nobody said yes. So you finish at 0 on one side and you finish at 100 on the other. You know, if it overshoots it, it's still 100. Right, back to the question. Why is that interval so large? Basically what you do is you take your answer and you add or subtract your margin of error. So that's where that came from. So why is it so big?
Well, it's called the conservative margin of error.
Correct, the conservative. Why is it so big? So anything?
Is it just a rough approximation?
Well, it's connected to this guy. If you only ask 27 people, won't this be quite a big answer? Imagine that I got this 26%, but I got it by asking 1,000 people, right? 1,000 OC students. Then wouldn't my conservative margin of error be 1 over the square root of 1,000? And in that case, the answer would be about 3%. So I could have said 26% plus or minus conservative margin of error. Can you see how close or how much closer that interval is? And that's a truism about every sample. In general, the bigger the sample is, aren't you going to get more information? And more information means that you can predict things with a fair degree of accuracy. Would you agree that answer is like almost everywhere? Could be anything. And the reason for that was a very small sample size. But if you can do a really big sample size, you can reduce that even further. Do you know, for instance, if I asked 1 million Americans or 1 million students, I guess I'd have to expand it to that, had they been to Mexico, couldn't I narrow that down to maybe 0.1%? So although I'm not asking every single person, can you imagine that if I ask enough people, I can get an answer that's darn close to being perfect? And conservative margin of error is a way of measuring how much wiggle room you would expect to get in your answer for any given sample size. Is that cool? Right. So for what time we've got left, we are going to, I'm going to nip over and we are going to look at the homework questions, just show you what they're like and put you on the spot and ask you to choose answers. So here we go. I think it's working. I'll see if I can make it big enough to read. There, okay. Okay. According to the fundamental rule for using data, which one of those 5 dots was closest to my dot, my definition?
The fourth one.
Yes, I agree. Oh, later on, not right now, but later on, we're going to get questions where I am going to disagree with WebAssign, because some of these answers can be quite subjective, right? You can imagine some questions can be a little bit, this is my opinion rather than their opinion, but not that. I'm not going to disagree with that because I think that makes perfect sense. Now, in each case, state briefly whether you think the available sample data can be used to make inferences. So in other words, is this a good sample? They could have just said that. Is this a fair representation sample, right? And they go through a whole load. And the first one is the heights of women in a psychology class could be used to estimate the average height of women at that college. Right, so I would, this is me, I would think, I don't think women who take psychology are taller than the typical woman or smaller. Would you agree? They're probably just the same variation as every other woman who goes to that college. And it is only this college that we're interested in. So one of those statements, it basically says the same thing that I just said. So yes, you could use it. And I would use that one. I think that's the phrase that and I think the reason why I choose this one and not that yes is it can be used to estimate. Would you agree that the answer you get from that class isn't going to be what you would have got if you measured every single woman's height in the college? Isn't there a little wiggle room when you do a sample like this, right? And if you wanted to know what that sample error would be, wouldn't it be 1 over the square root of n? Right, that's our little rule of thumb calculation. Now, parents of children attending a daycare facility are surveyed about whether the state government should increase funding to daycare providers to provide lower rates for lower income families. The data then used to estimate how much support the state should give, right? So this is only being asked to parents of children attending daycare center. Do you think that's a good sample to ask that question to? I'm saying shaking the heads, I agree with you. So it's going to be one of the no's. Agreed? So which no, because you can only pick one in these questions, do you think it is best suited to? The top no or the third no? I think I saw someone pointing 1. Let's read it and see what it says. No, the sample data cannot be used to estimate statewide support for youth funding daycare since individuals without children may have a different opinion than those with. Yes, I would choose that one. Does it seem reasonable that if you're going to ask people something and you really want the truth, you have to be careful who you ask, right? It's probably not a good idea to ask people on Bainbridge, are you in favour of increasing the tax rate? And it's probably not a good idea to ask people in other areas, are you in favour of getting more free stuff? Most people are in favour of getting free stuff, and most people are against paying for it, right? So you've got to make sure that when you ask people, you get a fair representation of them. Okay, here's a question about population. Looks like my dog's still telling me there's something outside. A political scientist surveys 200 voters randomly. Excuse me. The joys of teaching at home. I can't mute it, unfortunately, or you wouldn't hear me. I'm not sure that's not a bad thing, but anyway, a political scientist surveys 200 voters randomly selected. That's good. And he did it from all registered voters in a community. The purpose is to estimate the proportion of registered voters who will vote in the upcoming election. Okay. What's the population of interest here? Which one of those dots is the population?
All registered voters in the community.
Okay, so it'll be that one.
No, the community, not the
Oh, the
country.
community, sorry. Yes, and it's kind of, I guess, up there. That's where I would get that clue. Why couldn't they just go and ask 1,000 adults in that area, that community? That would introduce a bias. What would be wrong with just asking 1,000 people in Bremerton, no, of voting age, are you going to vote? Sounds all right, but there's a problem. I'm
They might
actually
not all be registered.
correct. I'm one of the problems. I'm not allowed to vote in America. I'm not an American citizen. I'm not allowed to vote, which is fine. You tell me I can't vote, I understand that. But, you know, if I was in that list, I would say, oh yeah, I'm not voting. But the reason I'm not voting is not because I could vote and decided not to, but because I'm not allowed to vote in the first place. You see, that could distort the data. Yeah. Although I have advantages in not voting. So your presidents, whoever you happen to vote in at the time, none of them are my fault. So you can't blame me for whoever you've got. You lot voted for that person, I didn't. So I don't feel the guilt when things go sideways. I can always say I didn't vote for him, it wasn't me. I didn't vote for anybody, so it was never me. And they go on and they talk about sample. This one's similar, there's nothing that exciting here. And here's one where you choose what selection bias is. Non-participation is this one. Okay, here we go. Let's see what's going on in question 7. In a class of 25 students, John, Maria, Inez, and Bill, etc., a random sample of 2 people will be selected from the class. Use the definition of a simple random sample to compare the chance of John and Marie will be in the group selected with the chance that Marie and Bill will be in the group selected. The 2 samples have the same chance. John and Maria have a larger chance to be selected in a sample. John and Maria have a smaller chance, or none of the above. If it's a simple random sample of 2 people, which one of those 4 statements is also true?
Is it the first one?
Yes.
Okay.
Would you agree the first two are going to be about the same chance as the second two, right?
Mm-hmm.
That's it. We've got time. Yeah, we've got time for one last one. I'm randomly going to stop. Where? I'll stop here. Question 10. In each of the following situations, have you noticed that your questions, your homework are picking dots? Right? You're not going near a calculator or doing anything. You're just going to read a lot, and then you might disagree. But remember, you get 5 shots. So if you do disagree, you'll probably find the right one eventually, won't you? Or at least the one WebAssign has decided is the right one, right? Fingers crossed. Right, in each of the following situations, indicate whether the potential bias is selection bias, that is caused by you picking the sample, non-response bias, that's when you refuse to answer, right, when enough people, and then we have the response bias. Response bias can happen when you go on a radio show and you say, okay, everybody, we're interested in blah, blah, blah. Phone this number right now and dial 1 if it's yes and dial 2 if it's no. You know, that kind of phone me up kind of thing. Now, why that's called response bias, which I don't think I actually wrote in my list, that is caused by people having to volunteer to take part. Right? So response bias. Now you say, well, why is that a problem? Do you know that most people, when they volunteer because they are strongly in favor or strongly against? Give you an analogy. Do you know that most HR incidents are about people complaining about someone else? There are very few HR responses where someone was saying, that guy Robertson's really nice, I like him. Isn't it more, that guy Robertson's a pain in the butt, he said this to me and he was cruel to me and he didn't do my homework or whatever, right? So you can imagine that is a response, isn't it? People volunteer to take part in something. That's the kind of analogy. So here we go. A survey questions asked an unmarried man, what is the most important feature you consider when deciding to date somebody? The results were found to depend on whether the question was asked by a male or a female. Your response bias.
Response bias, yeah, right?
Yes. And a different version of response. But can you see, if it's a guy, he might tell the truth, and if it's a girl, he might say something else, right? Some of them might say, well, I really like the color of the hair, which happens to be your color, and then try and chat them up, right? I'm exaggerating, but you know, that kind of thing. In a study of opinions about community issues, investigators randomly selected a sample of households, interviewed the person who answered the door. When no one was home in a selected household, a neighbor was interviewed instead. So they knocked on the door and nobody came. What kind of bias has happened there?
Non-response bias.
Yeah, nobody turned up. Agreed. So you'd go like that. Right, last one for today, and then we can say hi and get you out of here. A telephone survey of 550 people was conducted. People refused to talk to the interviewer. God, that was a lot. What one is that?
Non-response bias?
Another non-response. You can get that. Do you know if you do phone surveys and you say, we're interested in infidelity in marriage, have you ever been unfaithful to your wife? You're probably going to get a lot, I'm not telling you. Or you might get lies, which to me, a lie is the same as a non-response. The problem is you can't tell the difference, can you? Especially if they're very good at lying. So you're going to say hi. Do you want a joke before you go? Because I have just thought of one.
Yeah.
Okay. If you don't, then you're free to go. Let me remember to say hi before you go.